All right, so let's discuss limiting reactants and reagents. I will go back and forth. I guess limiting reactant is probably the better thing. What this does is, and we did this a bunch in class where we talked about how you run out of something. It'll involve starting materials, which are also known as reactants. There will always be two givens. So, for example, the simple way to look at this, if you have an Oreo that is comprised of having two Oreo wafers and then 3 grams of cream, and then you put all that together and you get one Oreo. And so, if we said you have, 40 wafers, and then you also have, let's just say 36 grams of cream. And the question is, how many Oreos can you make? Well, the Oreos you can make from 40 wafers, since each Oreo takes 2 wafers, that'll give you 20 Oreos, correct? And with 36 grams of cream, because one Oreo requires 3 grams of cream, that will give you 12 Oreos. So even though you have enough wafers for 20, the reality is you can only make 12 because you're limited by your cream, right? Your cream is limiting you. The wafers aren't limiting you. So we would say that the cream is the limiting reactant because it makes the least number of Oreos. All right. So when we go into a chemical reaction, it's not going to be much different than this. It's going to be basically, you're going to have something like propane and you're going to have something like oxygen. And let's say you have 10 moles of each, right? So here are our two givens. Our two givens are we have 10 moles of oxygen and we also have 10 moles of propane. So there's our two givens. And basically, we just got to figure out which product we want as long as we go to one. So this one actually asks for carbon dioxide specifically, but we could do the same problem going to water and just figure out which one makes the least amount. So because this is moles, and we discussed this already, that moles you can almost figure out. So 10 moles of oxygen, right, is twice as much as the 5 that the reaction needs. So for carbon dioxide, it'll give you twice as much carbon dioxide. So it'll give you about 6 moles of carbon dioxide. And if you're not sure how we did that, we basically just said from the balanced equation that for every 5 moles of oxygen, there must be 3 moles of CO2 produced. And that gets rid of moles oxygen. 10 times 3 is 30, divided by 5 is 6. So that gives us 6 moles of CO2. And now we'll compare that to what we can get from 10 moles of C3H8. So we will still have 3 moles of CO2 from the balanced equation, but now this time on the denominator, we're taking the 1 mole of C3H8, and then 10 times 3 is 30, so that'll make 30. So if the question is, which of these is limiting, it should be clear that this number is the lower of these two. So therefore, oxygen is our limiting reactant. Because this is the lower product yield or produced, right? It's the lower amount of product produced, so you're limited. Just like up here, we were limited by the cream because we didn't have enough cream to make more than 12 Oreos. Now we're limited by the oxygen because we don't have enough oxygen to make more than 6 carbon dioxides, even though we have enough propane to make 30 moles of carbon dioxide. We'll only make 6 because we'll run out of oxygen. All right, so this again features two givens, right? We had 10 moles and 10 moles. Now, as you've learned already pretty well now, When grams get involved, this becomes harder. So let's see if I can find one of those. Nope. All right, so let's just change this one to, let's say we have 94 grams of propane. So that's the blue one, right? There's that. So 94 grams of propane gas. Instead of saying excess oxygen, we're going to say that we have 65 grams of oxygen. Okay, so when grams are given, you know that the problem gets a little more complicated. So we have 65 grams of oxygen given as our one given, and then our other given is the 94.2 grams of propane. So we're going to do exactly like we did before. We got to get all the way to, now this time it's looking for water vapor. So we need H2O. And it's looking for moles. And the reality is you don't have to go to grams to figure out which one's limiting. Moles is just the same. It's just telling you how many groups there are before you figure out how many grams there are. So you can convince yourself of that as we go on through this problem. So we'll start with the propane. We need to cancel grams. So for that, we're going to need to consult the periodic table. And the periodic table tells us that carbon weighs 12, and there's 3 in this case, so that's 36. And that hydrogen weighs about 1, and there's 8 in this compound, so that's 8, and 36 and 8 is 44. And the units of that are grams. So because that's grams, we're going to want that in the denominator so that grams cancels, and anything from the periodic table is good for 1 mole of that material. All right, so then we're going to switch from the blue to the purple. So we know that there is 1 mole of C3H8 in the balanced equation, and that is good for, gotta go purple. That is good for 4 moles of oxygen of water. So this came from the balanced equation. As we talked about before, you better use that every time, and this came from the periodic table. So now we got 94.2 times 4 divided by 44. So basically 94.2 times 4 divided by 44 gives us 8.56. So this provides us with 8.56 moles of water, which is great. Now we're going to see if that oxygen gives us more or less. So we've done one with butane. Now we're going to do it all over again with oxygen. This time we're starting with 65 grams of oxygen. So we're going to have to go to the periodic table again. And we know that oxygen weighs 16, and in O2 there's 2. So that's a total of 32 grams. So again, the 32 grams will go on the bottom. 1 mole goes on the top. And then for our next one, so this came from the periodic table, just like above. Oops. And the next one we're going to get from the balanced equation. So we know there's 5 moles of O2 for every, and again, that's 4 moles of water. So this is coming from here in the balanced equation. And that'll give us moles of water. So, whoops. That'll give us moles of water. So 65 times 4 divided by 65 times 4 is 260, and we're going to divide that by 32. We're going to divide that again by 5, so it's 1.62 or 1.63. So of these two numbers, this is the lower number, and because this is the lower number, this must be the limiting reactant. And it dictates how much is made because we run out of oxygen after 1.63 moles of water. So the 8.56, even though we had enough butane for it, or propane, it's not going to happen. All right, so there's 2 more problems about that. And I will give you plenty of practice in class.